got to start the recording. Sorry about that. Via the question area on your interface there. So if you have any questions as we go along, whatever you want to ask, feel free. We'll get to them later. We might get to a few of them as we on the fly, but most of them we'll get to at the end. So Peter, take it away, and thank you very much for doing this today.
Absolutely. Thanks, Doug, and thanks everybody so much for being with us today. Like Doug mentioned, my name is Peter, and I'm with the Colorado Climate Center. The picture that you have on the title slide comes from Estes Park, Colorado, which is just about a half hour to 45 minutes west of where we are. And you can see a nice, beautiful cloud bank coming over the Rockies there. I think this is kind of a fun picture for this webinar because that for the central region, that's kind of the edge of your water supply. That's the edge of the Missouri Basin, the Continental Divide, right there with the stuff that you're seeing coming eventually into the Platte, and then the Missouri and Mississippi and stuff to the west, headed out west. All right, so we'll start with just a little bit of housekeeping before we get into the meat of the presentation today. So just a little bit of general information here. The webinars that we do monthly, or that Doug and Dennis really run, are made possible by an awesome collaboration between state climate offices, as well as a number of federal partners like NOAA, NCEI, the Weather Service, the Office of Atmospheric Research, National Integrated Drought Information System, as well as USDA climate hubs, regional climate centers, and the National Drought Mitigation Center. Our next call will be Thursday, March 17th, and that'll be at 1 o'clock, and it should be Central Daylight Time by that point, and your speaker will be the Illinois State Climatologist, Trent Ford. And then if you want to access this presentation or others, or get information about future presentations, we have the links here, and these slides will be available after the webinar. All right, so just a little bit of today's roadmap. We're going to start with looking at some of the more recent conditions that we've experienced. So focusing largely on what's happened since our last webinar, as well as just kind of a seasonal look at what's happened this winter in the last 90 days. We'll look at snowpack as well as soil moisture levels and stream levels. We'll then look at some longer term conditions, a little bit about what's going on at a 6+ month time scale all the way up to 12 months. We'll take a look at the drought monitor and talk a little bit about how we got where we are. And then we'll look a little bit at what's going on with the Great Lakes as well. Then we'll discuss some of the impacts that we're experiencing, both from wet weather and from dry weather. The impacts right now really do run the gamut with wet conditions in the east and dry conditions in the west. And then we'll look at where things may be going. So we'll talk, just briefly touch on some of the ongoing weather in the short term, but we'll talk more about what's coming up for us in the spring months, with La Niña likely on its way out, but also at the same time, it takes the atmosphere a little time to respond if La Niña does go away. All right, so just a little bit on recent conditions. So this is just a look at the National Centers for Environmental Information temperature and precipitation ranks across the contiguous US. So you can kind of focus in there on the northern central region. And we see that we had a bit of a split in terms of temperature, with colder than normal temperatures across the Great Lakes states and the Ohio River Valley, but then some warmer than normal temperatures out west. We also see that for the most part, it was a drier than normal month. And this actually fits in quite nicely with that pattern that you see of cooler than normal in the east, warmer than normal in the west. Some of those upper Great Lakes area, when it's cold, that cold air can't hold much moisture, as well as when it's cold, you oftentimes have kind of an Arctic weather system blocking moisture from the Gulf of Mexico or other moisture sources from penetrating into the region. And then oftentimes when you have warm conditions out west, it means you're likewise dominated by clear skies and high pressure, but more of a subtropical high pressure, or high pressure that comes more from the southwest. All right, so we're going to talk a little bit in this webinar about departures from normal, percent of normal. This animation's a little fast, but I just wanted to bring it in to talk about what is normal. And my point here is really that for most of the central region, the winter is the dry season. So like I said, cold air can't hold as much moisture, but furthermore, without the abundant sunshine that we get in the spring and summer, you just don't have the ingredients come together as often for those nice large thunderstorm complexes that give us our wet weather in late spring and summer. And you see the green pop up on the map there in, really April through July. All right, so now let's talk about how conditions have deviated from normal. And this is just a look at the last 90 days, and we do see a mix of conditions across the basin. We see that the Central Plains, particularly Kansas, Nebraska, and South Dakota, have been much drier than normal, but also that extends across much of the Corn Belt, with much of Iowa as well as southern Wisconsin and northern Illinois affected by the dryness. We also see wetter than normal conditions creeping into the eastern portion of the Ohio River Valley, and that's more the mode that has taken over recently, as we'll talk about, particularly when we get into the slides for February and the outlook, really. So then if we take a look at the temperature pattern that we've seen as well, we see that much of Minnesota, Wisconsin, Michigan have been cooler than normal this winter, with a large emphasis on really the last 30 to 45 days there with the cool temperatures. And we see that much of the Central Plains extending into the west portion of our region in Colorado, Wyoming, and Montana have been warmer than normal. This is somewhat typical for a La Nina year like we're experiencing, in that you see cooler anomalies to the north and warmer anomalies to the south. The cool anomalies don't extend maybe as far south or west as they often do in a La Nina, but we also have to factor in that with a changing climate, it's often warmer than our historical averages, so we get a bit of a tilt going that way. And also recent second year La Ninas, this being a La Nina with last year also being a La Nina winter. Oftentimes we see warmer conditions across the middle of the country. Our last two second year La Ninas were 2012 and 2018. Certainly applies for 2012, 2018, not as much unless you're looking more towards the southwest portion of our region. All right, this is what we've seen over the last 30 or so days, and you really see those cold temperatures in the eastern half of the region throughout the Ohio River Valley, as well as up into the northern Great Lakes states. You do see warmer than normal temperatures in the western portion of our region, where we've been abnormally snow-free. When you're snow-free like that, more of the sunshine in the winter gets absorbed rather than reflected. And also, if you have snow on the ground, you cool off more quickly at night. So when you don't have snow, you don't have that going for you as well. Just on the left-hand side here, I've posted some of the daily maximum and minimum temperatures from the Minneapolis-St. Paul Airport, where you can see some of the cold temperatures that we've experienced, as low as -16, which it definitely gets colder than that in Minneapolis-St. Paul, but still some legitimate cold going on. All right, this is a quick look at the current snowpack across the West US, and I've circled, or rather ovaled, the Missouri Basin. It's not an exact oval. If you'd prefer to look at the kind of bold blue lines, that'll give you a more defined outline of the Missouri River Basin. You see a mix of snowpack conditions across the upper Missouri River Basin, anywhere from 72% of normal to just over 100% of normal in the South Platte Basin. So we are definitely a little bit on the low side, and in some areas like the Black Hills, as well as parts of eastern Montana, that's definitely a concern, especially as we look forward to the runoff season in other areas closer to normal. So we'll start by looking at how that snowpack has built over the North and South Platte, some of the areas that are a little bit closer to, if not normal. This is looking at how snow has accumulated since the beginning of the snow season. The red line in both graphics is showing you an average snowpack buildup and runoff cycle throughout the year. And then the shaded blue areas show you what we have experienced this year. And you can see that we started below normal, but there was a nice bump around the holiday season that got us back above normal. And since then, things have regressed a bit. If we were to continue, you'll also notice from the title that these graphics are a little bit old. If we were to continue this out through the middle of the month, we'd see that the South Platte is right about average. The North Platte is just a little bit below average. And then this is a little bit further north within the Missouri Basin, looking at both total snowpack above Fort Peck and then snowpack from Fort Peck to Fort Garrison. So similar story with the red line being the average and the blue line being the current year's snowpack. A couple of other years have been highlighted here. The green year shows what you might see in a below normal year like we did in 2001. And then the dark blue and the purple traces show what you might see in a really high snowpack year. So as we get further north in the basin, we see that we're definitely below normal in terms of snowpack. And we're about 2/3 of the way through the accumulation season. So we're getting to that point where it's hard to make up the deficits that exist in snowpack. Here's a quick look at where we have snow on the ground across the central region. You'll notice that the eastern portion of the region, Ohio, Indiana, snow-free now, but that wasn't the case for a lot of the last month. We saw cool temperatures and unusually persistent snowpack across that area. Whereas if you look further to the west, we see a lot of the northern plains all the way up into Canada currently snow-free, and they've been that way for much of the winter, which is unusual, and certainly we could call that a bit of a snow drought and something that will affect the water supply as well as compound long-term drought issues that exist based on the conditions that we saw last year. All right, this is a look at soil moisture across the continental US. Again, you can focus in on the center of that picture to get an idea of what's going on in the north central climate region. We're seeing lower than normal soil moisture again across much of the central plains and extending into the Corn Belt. So it really kind of nicely follows that temperature anomaly map that I showed several slides back. One thing that Doug pointed out is that this depiction of soil moisture may be a bit too optimistic, with not showing below normal soil moisture across parts of eastern Montana, as well as the western portions of North and South Dakota. And I certainly agree with that. So maybe a little bit lower confidence in this depiction in that region where we do have long-term drought. And so soil moisture may be lower than what's being reported here. And then here's a look at current stream flows across the contiguous US with our region, again, in the middle of the picture. Here, the green dots represent areas where stream flow is in the normal range. Areas in brown or kind of that more orange or red, that's where stream flows are below normal. And then the blues are where stream flows are above normal. You can see a number of streams in the Ohio River Valley, all the way from eastern Ohio down to where it meets the Mississippi River, running above average. There's a number of streams still in the normal range, but a lot of rivers above average at this point. And once we get into the outlook, we can talk about how that's likely expected to continue. All right, so now I've got a few slides for you on longer term conditions. It's a little bit of a shorter section. And then after that, we'll get into impacts and the outlook. Okay, so this is a look at what we've experienced over the last 12 months as a whole. So ending in January 2022 and beginning in February 2021. Again, these are from the National Centers for Environmental Information, and we're looking at overall temperature rankings and precipitation rankings out of 127 years. So it was a hot, dry summer across much of the region last year, extending all the way out to the West Coast, with a number of states recording top 10 warm conditions over the last 12 months. And then we see, if we look at the precipitation pattern, that it's a little bit of a rich get richer, poor get poorer pattern. And that's a pattern that we're going to see emphasized once we get to the outlook here in a few slides. But we see that we're dealing with what are the normal long-term conditions in the Ohio River Valley, where conditions are climatologically more wet normally. But then as we go further west, where things get drier normally, we're also drier than normal. So if we look up in Montana, we see that Montana is 8th driest year on record from February of 2021 through January of 2022. And that the warm conditions last summer are also problematic in areas experiencing drought, because when things are warmer, you tend to lose the moisture that's in the soil more quickly. So here's a quick look at the current drought monitor depiction across the central region, and we see that much of the western portion of the region is covered by drought. But again, that does extend into the Corn Belt, with much of Iowa as well as Wisconsin and northern Illinois covered by some level of either moderate or severe drought, as well as areas that are D0, or what we just call abnormally dry. It's not quite technically drought, but it is leaning that way. If we look at the western portion of the region, we really see both the soil moisture drought in Kansas and Nebraska and eastern Colorado highlighted, as well as some of the lack of snow combined with long-term drought and soil moisture drought in Montana and northern Wyoming, where you really have both short and long-term impacts ongoing. This is how things have changed since our last webinar. So just the change over the last 4 weeks, and you can see that there have been some improvements, some marginal improvements in my area in Colorado. We've had some decent snowstorms where the Denver metro area has improved by a class or two. However, if we look at the majority of the region, there's a lot more degradation happening than there is improvements. And with the warm, dry conditions across the center or central plains, that makes a lot of sense. I've got a couple slides just giving us a quick look at what's going on with the Great Lakes, both in terms of current storage and current ice cover. Here we see the areas that are marked in the grayer areas are areas that are currently ice covered. So you see a lot of ice around the periphery of the Great Lakes. And in some of the areas like Ohio or around Lake Erie, where things have been colder than normal, you do see quite a bit of ice. And this is also about peak ice time of year. So here, this slide is showing, integrated across the entire Great Lakes. The red line is the buildup and melt out of ice in a normal year. The kind of lighter purple shaded areas are given, ice time series that we saw in previous years, ice buildup and ice meltout. And then the dark line, the black solid line, is what we've seen this year. So this is right about the time of year that we'd expect ice over the Great Lakes to peak, and it has peaked a little bit above normal. I would say this is more or less a normal year in terms of ice. We'll see what happens over the next few weeks with more cold air coming. It doesn't quite meet the way above normal years that you see in some of those traces where we've seen as much as 80% ice cover, but it's peak ice season and the data reflect that. Okay, just a couple slides showing water levels over the last couple years for a few of the Great Lakes systems. This is Lake Superior going back to 2020 through 2022. And you can see how lake levels have come down. And in many cases, that's really a good thing, because 2 years ago, they were at record levels or too high 2-3 years ago. So Lake Superior, you see the average in that blue dashed line. The record highs and lows are given in the black lines for each month, and then the red line is what we've experienced. And then the hashed area is sort of the projection going forward for this year. So Lake Superior, a little bit below normal storage right now, but ticking back up, or projected to tick back up to near normal this spring. The Lake Michigan Huron area has come down a long way since the 2020-2019 timeframe. Again, that's probably a good thing, still above normal, and it's likely to stay that way, but stay more sort of within that normal range. And then finally, Lake Erie, similar story, it's down, but still above normal. Okay, now let's get into some of the impacts that the region is currently experiencing. We'll start our story out in Kansas, where we've seen dry conditions and warm conditions over the last number of months, and especially down in southwest Kansas, this has been a problem with ponds and creeks drying out, particularly a problem if you're trying to feed livestock. And then this is also getting into Kansas's typical fire season. The reason being, those grasses are dormant throughout the winter and they dry out quite quickly when you have warmer, windier weather during the winter and early spring prior to green up. So the Albright fire recently burned over 1,000 acres and forced evacuations. Other side of the coin, also in Kansas, we had a heavy snow band at the end of January in eastern Colorado and western Kansas that dropped 27 inches of snow on Mount Sunflower, which is the high point in the state of Kansas, out near the Kansas-Colorado state line. And that did have some kind of normal winter transit impacts. Ag impacts, we definitely have a list of concerns going into this growing season. Winter wheat has a number of ongoing concerns. For instance, in Colorado and Kansas, it was dry around planting season. So with dry, hard soils, some of that wheat had to be drilled in. It's not as easy to keep it in the ground when conditions are like that. And we saw quite a bit of wheat lost from an extreme wind event back in December. Some moisture is definitely needed across the Central Plains into the Western High Plains prior to green up season. We really need some good, timely $1 million rains that will help build the grasses and feed the cows come that time of year. We also saw some poor stands out on the other side of the region in Ohio, but we're in wait and see mode. Looking further out east like that, we also have the concern that the current and ongoing wet weather could lead to some delays in planting once that season starts. One thing that I noted with cattle is that we're now down to the lowest level of cattle in the US since 2012 and that drought. And when you have cattle sold off as a result of drought conditions, that's an impact that takes a long time to recover from. It takes a long time to build back up your herds after having to cull as a result of dry conditions and not enough forage. In terms of transit impacts, probably don't need to spend too much time here. Pretty normal winter transit impacts. This picture on the right was sent to me by Trent Ford, who will be your speaker next month. But the blizzard from St. Louis to Chicago, that area, in the first part of the month, I believe that it was the first week of February, had quite a number of accidents associated with it, including quite a few trucks, 18-wheelers off the road. There are some ongoing problems with urban flooding with the storms that are coming in as we speak in the eastern part of the region. And then I just noted a couple of the transit impacts that we've had in the Denver metro area over the last month or so with a freezing rain event and then a heavy snow band that occurred during a rush hour on a Friday. Hydrologic impacts, these run the gamut. So you have the wetter than normal conditions in the eastern part of the region, particularly in the Ohio River Valley and near the main stem of the Mississippi in southern Illinois, where things have been both cold and wet, which is conducive to things like ice jams, as well as just high rivers in general. And then on the western edge of our region, you have lower than normal snowpack and low soil moisture. So some moisture is needed prior to this growing season. All right, so how likely is all that? That's where we get into the outlook. And we'll start with the 7-day forecast. So, we're in a very active weather pattern, and those of you who may be in the eastern portion of the region are experiencing that right now with quite a bit of precipitation coming in as we speak and snow falling across, again, Missouri and Illinois. This system will sweep out pretty quickly, and then we'll get warmer across the region, warmer than normal for most of the region this weekend, before another weather system comes in, lowering temperatures once again. And that's where you see the possibility for some snowfall across the Dakotas and eastern Montana. But once we get into the 8 to 14 day time frame, it's apparent that winter is not over. There's a high likelihood of more cold air or another big cold snap towards the end of this month. And some of the values that I've been seeing in the weather forecast models for Minnesota and the Dakotas could bring temperatures as low as -30 on the coldest mornings during this time frame, and could bring the below zero temperatures as far south as Oklahoma. We'll just have to see on that, but the main point is that winter's not over, and we're still gonna potentially have to deal with some impacts from very cold weather. Just to kind of cement that, we now are looking at the 8 to 14 day temperature and precipitation outlooks as provided by the Climate Prediction Center, where we see that there's an increased probability of below normal temperatures all across the region over this time frame. And then in the 8 to 14 day outlook, we see potential for more wet weather out east. So certainly potential for some of those rivers that are already high to get even higher. And then things revert back towards drier than normal in the western portion of the region, where some of the moisture is needed the most. Okay, now I just want to briefly get into what's going on with La Niña and what is expected going forward. We've got a couple graphics here. The one on the right is showing what's happened with La Niña over the last year through this fall. It's not completely up to date, so it doesn't show quite where La Niña peaked this winter, but La Niña peaked with sea surface temperature anomalies in the eastern Pacific of about -1 Celsius. So kind of a week 2 moderate, more moderate leaning La Niña, not quite as strong as the La Niña that we saw last year, but La Niña nonetheless. And then the slide, or the image rather, on the left-hand side of the picture is showing the forecasted probabilities of La Niña, neutral conditions, and El Nino conditions going forward through the spring, summer, and even early part of next fall, where we see that this La Niña is likely to weaken throughout the spring and may give way to neutral conditions this spring and summer. There is a bubble of warmer than normal water in the Pacific below the surface in the eastern and central equatorial Pacific. The way that tends to work is the warmer water will eventually work its way up to the surface, which will kill the La Niña pattern that is in place. Not a certainty that that's going to happen, but that's definitely the way that things are leaning. But it does take the atmosphere a little time to respond to that kind of change. So this is just the why do we care slide. This is showing the impacts of La Niña in the North America area, so across the contiguous US and Canada. And oftentimes during La Niña, the pattern that you get is high pressure off the Pacific coast, as well as more of an Arctic high pressure air mass across the Canadian Shield. And this tends to force a strong jet stream in the middle. And so we see a lot of our low pressure systems develop off of the lee side of the Rocky Mountains or eastern side of the Rocky Mountains. And as those track across our region, across the Central Plains, they pick up steam, and eventually once they reach the Ohio River Valley, pick up some moisture from the Gulf of Mexico, and we tend to see a wetter pattern in that area during La Niña years. We're at El Nino, you don't see as strong a high pressure typically off the west coast, and you see a weaker jet stream, which tends to make things a little bit drier for the eastern part of our region, but also opens the door to the Pacific to some extent for the southwest portion of our region, and can lead to higher precipitation and snowpack values in that area. So here's the outlook for the month of March, and you'll notice that it's definitely a La Nina leaning pattern that we have going forward. We see the increased probability of above normal precipitation on the right-hand side here for the month of March in Indiana and Ohio, as well as eastern Illinois and going up into Michigan, as well as a slight tilt towards above normal precipitation in the headwaters of the Missouri River Basin, where snowpack is on the low end. So we'd certainly welcome that. However, some of the areas that are drier now also lean drier during La Nina in spring. This includes eastern Colorado, as well as western Nebraska and western Kansas. In terms of temperature, this looks somewhat like a La Nina pattern, although you see that above normal temperatures are favored across most of the region, and you don't see that below normal tilt in the northern portion of the region in really not only Montana, but extending into the Dakotas and northern Minnesota. It's more tilted back to the west. So part of this is a climate change signal where we generally expect temperatures to be warmer than average, all else equal, as conditions continue to warm. But also part of it is looking at seasonal forecast models. They're holding the cold air a little bit further to the west than maybe a typical La Nina. Once we get into the March, April, and May timeframe, you don't see any huge changes to that really. So we still see this rich get richer, poor get poorer pattern where we're likely to have, or at least have an increased likelihood of above normal precipitation in the Ohio River Valley and part of the Mississippi River main stem. But we also see this tilt towards below normal precipitation in the southwest corner of our region, including Colorado and some of the nearby central plains. And once you get into May and even June, July especially, if you have low soil moisture during the warm season, you can get into what's called a land atmosphere feedback, and that's basically to mean that if you have dry soils, you have less water to evaporate into the atmosphere, and if you have lower humidity values, you're less likely to generate thunderstorms, is what I mean by land atmosphere feedback there. So this is the sort of lead two outlook for the Climate Prediction Center. This is looking at temperature and precipitation for the April, May, June timeframe. And again, we see that not a lot changes. So we are expecting an increased tilt towards below normal precipitation in the southwest portion of our region, and an increased tilt towards above normal precipitation in the eastern portion of our region. So the places that really don't need it as much are getting it, and the places that do need it, likely not as much. Okay, along with that is just a little bit of a summary of what is going on at the River Forecast Center level. So this is a look at river projections through April, the probability of rivers reaching minor, moderate, or major flood stage over the next 3 months. And we do see some high probabilities in the Ohio River, of the Wabash River, as well as some other rivers in the area reaching the at least the minor flood stage, if not the moderate flood stage. This map is from last week, so it doesn't include the storm that's happening now. And I suspect that a lot of this has actually updated to increase the chance of rivers reaching flood stage in the region.
Yeah, I'm going to comment real quick on that.
Yeah, of course.
Can you go back? Sorry about that.
Yeah, no problem.
Yeah, so I think this is the Ohio River Basin. It's hard to see the states very well in here. I apologize for that. But this is the area that's, if you will, under the gun the most at this point for the region that we're talking about, the north central part of the U.S. Partially because of what Peter's been saying about La Nina. And so where you see red and orange, there's a higher likelihood of reaching flood stage on a number of those rivers. And this is a long-term view. This is not what's going to happen tomorrow or the next day. There was something we got sort of late in the game today, indicating that a number of these sites would likely see at least minor flooding because of all the snow and rain that they're getting, and are going to be getting over the next 10 days. Okay, so if you're in that region or if you're interested in that area, I think you already showed the quantitative precipitation forecast, which is this next 7 days, which shows quite a bit of water falling. And that's not surprising. It's very common during this time of year with a La Niña in the Ohio Basin. Okay, on you go. I'll be quiet. Sorry.
Yeah, thanks, Doug. Definitely helpful context. And Doug did send me a slide late in the game that showed more of a short-term projection based on what we're experiencing now. I will go ahead and make sure that that is included in the final presentation available online. Moving on, this is a look at the longer game projection for the Mississippi River Basin. And so here we're looking at the upper Great Lakes states down into Illinois and Missouri. And we do see some areas where there's at least a 50% chance of the minor flood stage being reached. But the biggest story is up on the Red River in North Dakota, where many gauges have at least a 50% chance of moderate flood stage being reached. And at least one gauge there has a 50% chance of major flood stage being reached. If we look now to the Missouri Basin, we see on the James River that there are several gauges where there's a high probability of major flood stage being reached. There's been, good snowpack throughout much of Northeast, North Dakota, and the rivers that are running out of that area are going to see a high probability of or a higher flood risk this year than a normal year. And then just with everything pooling into the Missouri, we're seeing some areas where there's a 50% chance or greater near the Missouri main stem in Missouri as it flows into the Mississippi.
Again, I'm
All right, so
I'm gonna butt in there one more time just to make sure we get this right. Back it up, please. So the James River flows from North Dakota south into the Missouri, and so you can see the purple up there where there's some concern about major flooding on the James. It's a very flat river, flows extremely slowly. The lower part of the basin, you'll see that coloring, the orange and reds, every single year, mainly due to spring convective, what we call convective, which is thunderstorm and such activity. It's nothing, I hate to say this, it's nothing special. Of course, if you're caught in a flood, it is special, but it's nothing out of the ordinary is a better way to say that for the lower part of the basin to have a little heightened flood potential in the spring. Overall, though, the Missouri Basin has a less likelihood of normal for flooding at this point. Okay, on you go. Thank you.
Yeah, that makes a lot of sense with the lower than normal snowpack values that we saw earlier, as well as some of the areas where we're bare of snow where we wouldn't be in a typical year. So it makes sense that the increased flood risk that you see down in Missouri is more of a localized effect based on thunderstorms. All right, so we can sum up there. Most of the central region is coming off a dry year, although we're definitely a ways away from that in the eastern part of the basin, especially now. And we're more generally in the time of year where this is the hydrologic recharge phase, where we tend to see soil moisture recharged as the weather gets wetter going into the spring, but before our northern hemisphere ecosystems really wake up for the spring-summer season. And that's where we tend to have the highest stream flows and the worst flooding problems. And that could certainly be an issue in the Ohio River Basin. We're dealing with the opposite effects in the western portion of our region with lower than normal snowpack, again in the Missouri Basin, as well as a lot of areas experiencing a combination of soil and snow drought. And some of those impacts really work their way all the way across the Corn Belt into Iowa, Illinois, Minnesota, and Wisconsin. When we look forward, a lot of the forecast for the next couple months is based on having a La Nina signal still present. Like I mentioned, it is weakening and could die out entirely by later this spring. However, because it takes the atmosphere a little bit of time to respond to, I guess you could call it the death of a La Nina, the long-term, climate models are holding more of a La Nina signal over the region. All right, so again, we'll wrap up there. Here's some links that you can check out if you want more information, as well as if you wanted to revisit this presentation later and look at some of the past presentations, you could look at some of the links from the very beginning of the webinar. And then here are some of the folks that you can contact if you have questions about today's webinar. That's all I've got for you. Let's open up the phones.
All right. Well, thank you. And we do have a few questions. Yeah. So let me go to the questions real quick. Dennis, do you want to say anything overall? I think we had some general comments about 2012. Maybe we'll start with that. Comparisons, I'm sorry, to 2012. And I guess we'll call that concern. And first of all, I'm going to say before Dennis says anything, yes, we are concerned. But maybe not in the same way, at least not yet, in the same way we might be in 2012. There were quite a few differences between the 2 years. But go ahead, Dennis.
Yeah, there are some similarities to 2012, but there are some differences too. So, I mean, we are coming off what we call a double dip. La Nina's in two consecutive years. We did the same thing back in 2012. So there's that similarity, but there are other sea surface temperature differences that we note. We didn't look at those today, but there are some other sea surface temperature differences from 2012. We had a very dry fall throughout, parts of the plains back in 2011 going into 2012. Not quite as much in this time frame. And we mentioned, 2012 really cranked up quickly by getting very warm and dry in the spring. And right now, we're not necessarily seeing that same kind of crank up yet. Could we have another 2012? Sure, it's possible. But right now, it doesn't seem necessarily that much more likely than any other kind of year.
Yep, and the antecedent conditions in 2012 were, we'll just go back to 2011, were extremely wet in the northern part of the Missouri Basin and other parts of the northern part of the country, but dry, very, very dry in Texas, Oklahoma, that area, if you remember. So that was one difference. Also, it was record-setting heat for 2 or 3 weeks in March, where we saw the 80s in Michigan, all the way west. Michigan wasn't alone, but Michigan was really sort of an epicenter for part of that time, which is very, very unusual.
The one thing that we're on the downside is the overall background drought conditions are worse
right
now than they were back in 2011.
Right. So while it may not be like 2012 in terms of how the climate's playing out, the severity of drought we could equal it in a different way. Which is,
or in a different place.
In a different place. That's true. That's right.
Yeah, I need to be careful bringing up 2012 because that was a scary year, but right, especially if you look at the current conditions and where the outlook is going, there's a lot of concern for the western portion of the region.
Right, right. And you really put a mark on that, Peter, with the snow, lack of snow, mainly in the lower elevations, but also across the upper Missouri is at this point is lacking. It'll be hard to catch up. And there's another comment in here about even if we had, I'll just read it. It's from Bryce. It says, does equal chances on precipitation offer much for soil moisture improvement in the drought areas of the northern plains? It seems not, with vegetation taking up the moisture it actually occurs. Well, a couple things. Yes, moisture, and number two, the fact that soil moisture is already dry. There's not going to be a lot of flow once there's not going to be a lot of overland flow or replenishment of reservoirs and things like that because the soil's so dry, it's going to take up a lot of that. Plus, yes, vegetation will be trying to grow as well. So I think one of our major points that we wanted to get out today was that without substantial moisture, and yeah, we're getting closer and closer to the spring rainy season, without substantial moisture, the level of risk rises each day that we don't get that, or really puts the emphasis on that spring moisture. Okay, whereas if we go into spring pretty wet, maybe we're not so worried at the moment of getting that April-May precipitation. So, but we're not.
Yeah, and then of course, sorry. Of course, it's also worth reiterating that when you see equal chances, that does not mean an increased probability of normal. It means that we just don't have an idea which way the tilt is going at this time based on what we're seeing in the models. However, if you were, and Doug or Dennis, correct me if I'm wrong here, but if you were to get, say, normal precipitation in March, April across the Corn Belt, Dennis's turf, kind of Iowa into Wisconsin and Illinois, those areas typically you see soil moisture recharge in a normal year this time of year. So if we could get normal precipitation over the next 2 months, that would at least help. I don't know if it would get rid of drought concerns, perhaps not, but it would help.
Well, okay, we got to be careful about our areas here.
Okay.
The area from Illinois to the east, Illinois, Indiana, Ohio, is already wet.
Yeah.
And we have increased chance of wetness already. So that's a different set of concerns. We're concerned about too much moisture there. Yeah. And then Iowa's kind of that dividing line between where it's wetter and then we start getting drier, and then you get out of the plains and you have much drier. And that spring, the intensity or the expectation of biggest precipitation is in the spring out in the plain states. So that's a much more critical time there, whereas we have more time for rainfalls to occur, and we don't want too much more rainfalls to the east of Iowa per se.
Yeah.
Another question is the IRI and CPC, for that matter. A number of the models have pushed La Niña a little further into the spring with a little higher percentage of it occurring. Yes, that's true. And one of the things we've found is that winter, December, January, and February aren't always the best indicator of how a La Nina or El Nino is going to affect an area. Often it's the February, March, April time period where the impacts seem to be the greatest. Not every year, of course, but in some years. With La Nina, that seems to be the case, especially in the Ohio Valley. And we're seeing that with a propensity of the precipitation kind of moving or, occurring in that area from basically Missouri, to West Virginia. Any comment on La Nina being pushed a little later? Either person? Or no? Or impact?
Briefly, some of the models have held on to La Nina. There's a bunch of different models that are used as computer models, are used as indicators. Some of them are holding on to the La Nina longer. In fact, there was one that held it out all the way through summer without even weakening it very much. That seems to be the outlier, but that is why the outlooks have shifted and held on to La Nina a little bit longer in the spring to reflect some sensitivity in the models towards La Nina holding on. Still expect it to go away by summer, but we are lengthening the time that there could be some La Nina influence.
In that, I would say that's important not only for the Ohio Valley, but also for the central and southern plains, maybe even sneaking into South Dakota to some degree, where, although not a strong correlation, but a decent correlation with warmer and drier conditions, which won't help the situation that's already dry out there. So there's a level of concern on our part as well. Dennis, I think one thing we should probably talk about in terms of crops generally is that timeliness of any precipitation can help certain crops like wheat, even if we're still below normal. Do you want to say anything along those lines?
Yeah, and again, you're looking at a couple different situations. Wheat, has taken a bit of a beating because of drought, because of the strong winds, wind event back in December. Wheat in the plains has taken a bit of a beating. There's a joke that wheat has 9 lives. If we can get some moisture on it in the spring, there's still a chance of it doing decently. But there is still, a significant level of risk. Rangeland further north in the plains, we have significant concern about because we need moisture on it this spring, especially after a bad year last year. There's a bit of memory in rangeland. We need rainfall, even a couple blizzards. While people don't want those bring moisture. Those would be great. As you get further east into the Corn Belt areas, we actually need precipitation kind of to stop, because especially to the eastern areas, we're looking more at having soils that are too wet to get out and do things in the springtime. And then the winter, there's some winter wheat that has grown in the eastern Corn Belt. The wetness has not been so good for that over there either. And then we don't want to forget, like, there's some Minnesota, Iowa areas that are continuing with drought too, that need some additional precipitation. Not too much, but some need to help with a bit of soil moisture recovery there.
Quick question from Bryce, another one aimed at you, Dennis. Prevent plant risk. That means not able to plant because it's too wet in eastern Corn Belt and Red River Valley of the North. Red River of the North.
Yes.
Yes.
Definitely. Yes. And that is part of crop insurance that was introduced after 93, I believe, 1993, that if it's too wet, you get a settlement. You have to maintain the soil afterwards, but you don't try to plant when you can't get in there. Quick reminder of people too, I don't think Peter quite touched on it, the Red River of the North, the problems we have up there. We had a wet fall, and they have a decent snowpack up there, and it's a very flat, north-flowing river. So that's why, those two things really lead to flooding events up there. Wet falls and decent winter snowpacks increase their level of flood.
Yep. And let's see. We did not talk about frost levels or frozen ground very much in this webinar. Sometimes we don't have all the data that we'd like to on that. However, that said, a rule of thumb is where you do not have snow cover, especially I'd say Nebraska North, Iowa North, whatever, especially in those areas, without snow cover, you're going to get deeper frost levels, if you will, without snow. Now, luckily, it's further east you go into Iowa and Minnesota and all that, and eastern North Dakota, they do have relatively good snows, and so the level of frost isn't that deep. Further west, however, I think we're seeing more penetration of that frost. And yes, the comment was we need the rain, but not on frozen ground.
Yeah. The thing you have to remember, though, Doug, is we were relatively warm to start the year, and the plains have been relatively warm, so their soil wasn't freezing as readily. Yes, it will start freezing now with the cold, but it won't have the chance to go quite as deep because we didn't get started as earlier.
Right. Well, yeah, like I always say, it may be warmer than normal in western North Dakota, but the difference between -30 and -20 isn't much. So on we go. Really great ag precip comments. They like that. Here's another question. Oh, Kansas, Nebraska drought degradation expected to increase as drought continues to intensify in the West. Texas, Oklahoma. When is the last reasonable chance to turn it around? So that's a great question. I'm scares me to try to answer that though. So I'll give it a shot. It really depends on what I'll get out of it this way. A good question, Doug. It really depends on what you mean by turning it around. Like Dennis was saying, with winter wheat, timely rainfall, it's fine. even through a drought, right? Even through a drought, a timely rainfall is all that matters, and that's harvested in July or whenever, June, July, maybe a little later. Other things, it's a totally different angle. So, water supply for communities. We've already had a few on the lower Missouri. There's been issues with not enough water in the Missouri River due to for a number of reasons, but partially because of drought and low inflows and all that stuff. Also with energy, not being able to or getting close to times where cooling for production of energy is troublesome if there's not enough water. So those are kind of things that we want to solve, obviously, drinking water and energy production, as well as agriculture, I guess I'd say. So as far as turning it around, yeah, timeliness matters a lot with ag, less so with reservoirs and such. You just need the water.
Yeah, I don't know if there's, any one tipping point. You did a good job with that. Certainly the later you go without getting the moisture, the more nervous you get. And at least here in Colorado, and this probably extends out into parts of western Kansas and Nebraska, you want to see at least one or two good storms to help turn it around by mid-May. Again, I don't know that that's really a tipping point, and it certainly varies based on what you're planting and where you are, but the western end of the region, particularly the area that I'm familiar with, late April and May are kind of the money months.
Yeah. Yep. Right. Yeah, that's key for short grasses and rangeland and everything else, as well as other crops.
Yeah.
Barge limitations on the Missouri projected. I think the Corps is projecting, and I can double check this, but there's minimum navigation is projected for, I think they said the first half of the year or first half of the navigation season. Eek. Now I'm not sure, and if somebody from the Corps is on and wants to comment on that, please do in the question part. I know there are, I don't know about limitations, but I know it's minimum flows for the navigation season. Okay, Brian, there has been some irrigation on wheat in north central Nebraska to try to help it along. Oh, already irrigation. Okay. Thank you, Bryce. All right. I think that's it. We've reached, almost exactly the top of the hour. I'm going to say thank you to Peter and Dennis. Dennis from USDA Climate Hub, Peter from Colorado Climate Center. Thank you both very much for your input here. It's been a great discussion. I hope people got something out of it. And we will see you next month with our Trent from Illinois. And until then, take care and hope it rains where it needs to and doesn't where it shouldn't.
Yep. Thanks, Doug. And thanks everyone for joining again.
Yep. Thank you. Bye-bye.